This video covers the light year unit and the somewhat more interesting concept of lookback time. The light year is the distance light travels, through a vacuum, in 1 year. Space provides a pretty good vacuum, so this is basically the distance light travels through outer space in 1 year. In miles, this is a distance of 6 trillion miles. We see objects because light has come from those objects, either by the emission or reflection of light, and it reaches our eyes or telescope. It takes time for the light to get to us from those objects. The farther away an object is, the longer it takes for the light to reach us. Thus, the farther away an object is, the further back in time that light was emitted. Therefore, the farther away an object is, the further back in the past we are seeing it. This is the concept of lookback time. When you look at objects in a room, the light was reflected off those objects a few nanoseconds in the past. A nanosecond is 1/1000th of a second. This delay isn't an issue, or even detectable by our eyes and brain. However, due to the vast distances to many objects out in space, this can be much more relevant. For objects that are within a distance of about 100 million light years, the light year unit can be handy when it comes to lookback time. For example, when we look at an object that is 10 light years away, we see it as it was 10 years in the past. That is, we are seeing it 10 years younger than it actually is. When we want to study very young galaxies, we point our telescopes to the most distant galaxies that we can detect. We can now see galaxies as they were within 1 billion years after the birth of the universe. As a simple silly example of how this works, imagine a stadium full of 20-year-old college students. In this example, suppose the speed of light is very slow. In fact, it takes 50 years for the light to completely cross the stadium. They enter in the darkness and the lights are suddenly turned on. The students then sit there for 50 years. That would be a long game. Suppose you were the person sitting on the right side in the illustration. What would you observe in 50 years? You would be 70 years old and the people right next to you would also look 70. However, people who were sitting farther and farther away would look younger and younger. In fact, the first light from the guy sitting on the opposite side of the stadium would just now be reaching you. He would look like he was still 20 years old. This is the effect of lookback time. As a more realistic example, we can imagine exploding stars at different distances away. The distance is listed on the first column. The year it exploded is in the middle column and the year we observe it exploding is in the third column. The idea is to take the information given in a row and try to figure out what goes into the cell with the question mark. In the first row, if a supernova occurs 10 light years away, and it explodes right now, then when would we see it? If it is 10 light years away, then it is going to take 10 years for the light to get here, so the 10 goes in the third column. In the second row, if a star explodes that is 100 light years away, and we are just now seeing it, when did it explode? If it is 100 light years away, then it took 100 years to reach us. Thus, it must have exploded 100 years ago. See if you can figure out the last 2 rows on your own. We believe the universe started almost 14 billion years ago. We can only see objects from which the light has had time to reach us within this 14 billion year time span. Objects in the universe that are too far away are not visible to us because the time required for the light to get to us is too long. Thus, there is a visible horizon, beyond which we cannot see. However, the distance to this horizon is not 14 billion years, but is actually much farther. It was discovered in the 20th century that the universe is expanding. On the largest scales, galaxies are moving away from each other. Thus, by the time we see light from a very distant galaxy, it has moved much farther away from us by the time we see it. Based on our current models of the universe, the farthest objects we have observed are around 47 billion light years. The visible horizon boundary is believed to be around 93 billion light-years.